Good morning. Today I am going to discuss the second part of the Pandas programming. So in this part, I will be discussing a bit advanced methods and attributes available in Pandas data frame. So this is my 6th lecture in the series. So let us move to the programming window. So this is what I have in the Spider IDE environment. So in this, first I am importing the Pandas and NumPy. Pandas as PD, NumPy as NP. Now I am taking a dictionary. I am taking a dictionary by name, student details, same thing which I have taken in my previous lecture, or I have modified a bit, it may be. So this is what, when I execute the selected code here, so I am getting the student details. The dictionary is printed here. Okay. So this is the dictionary, student details. I will print it here again. So this is the dictionary. So in this dictionary, I have roll number, key. Under this, I have 1, 2, 3, 4, 5, 6, 7, 8. 8 values are there for this key. Second key, student name. Third key, marks, underscore English. Fourth one is marks physics, marks mathematics. Sixth one is. Okay. So this is what is the dictionary. This dictionary I am transferring to Python data frame. Okay, that is Pandas data frame. So Pandas data frame, I have given the data, I have pointed this data to the student details, and I have created an index. Index is the row labels basically. I am calling this by A, B, C, D, E, F, G, H, and this is a list here, list of string, and this is given as index. Then, so here, so once it is executed, the dictionary is placed in the data frame DF here. I am printing this one by executing this selected code. So when I see here, I have now this is the DF data frame, Pandas data frame. I have the roll number, student name, marks in English, marks in physics, marks in mathematics. These are the column labels, and this A, B, C, D are the row labels. And here I have, how many I have? I will check the size of this one. DF dot size. What is DF dot size? 40. 40 means 8 rows and 5 columns. 8 rows and 5. These are the 5 columns. So these are the 8 rows. 8 by 5. 40 is the size. That is the total number of entries in the table. Then I am using attribute, another attribute that is ndim. So n dimensions. What is the number of dimensions? If I see the dimensions is 2. One is along rows and columns. These are the 2 dimensions here. Because it is a table. Table is always a 2-dimensional table. Normal table, spreadsheet table is nothing but a 2-dimensional array. So it has a 2 dimensions. It is showing 2 dimensions. Then I have another attribute that is axis. So let us execute and see this axis, what it is. So here, this axis, that is, you can say that x-axis, y-axis like that. So x-axis compared to normal plots, the way we plot the things. So you can take the column labels as x-axis and row labels as y-axis. Okay, with respect to the line plots. So this is the index. So basically what is it? This axis is outputting the row labels and column labels. Now this is of size 2, and 2 rows basically, the index is 2. So access is it contains 2 objects. One object is column labels, other object is row labels. So let us extract the access of 0 at the 0th index. So what it is giving? It is giving the row. So all this is data type is object here. Okay, see here. So this is data type is object. See in the console. Here I have this. In the console I have this. Please see here, D type equal to object. So this is the row labels constitute an object. Then df dot access 1. So extract the second one. So this is nothing but the column labels. This is another object. So these are 2 objects. These 2 labels are objects. Now let us see the method here. This is not the attribute of the data frame. This is the method. Info braces. So it means it is the method. So df dot info. Let us execute this command. So what we are getting here? We are getting a table here giving the information about the different data types available in the columns. So here when I take, there are 5 columns. They are indexed as 0 to 4. First one is roll number, and it is a non-null object. That means there are no null values. That means there are no missing values in that one. Okay. Then it is an object. And student name. Similarly, there are no nulls in this. Total 8 are there. Because why the 8? Number of rows are 8. So this is non-null. Data type is object. Then take marks underscore English. So this is the label, column label, and this also has 8 non-null items, and this is data type is integer 64. So similarly, marks underscore physics, marks underscore maths, both are 64-bit integers. So this is what we have totally in this one. It is describing, it is giving the information about the data types. So here 64-bit integers, 3 are there. There are 2 objects. Okay. So this is what is given, and the total usage is 384 bytes. This is what is the memory usage it gives. So this is what the df.info, this is df.info method outputs. Now let us see next one. So what I am doing here, see in the code here, I have taken df indexed by column label, that is marks English dot values. So what I am doing, I am taking this data frame. From the data frame, I am taking out one column by label marks English, and I am finding the values in that one. What are the values available in that one? And those values I am assigning to data 1. Okay. So let me select this and execute the selected code. So I got here data 1, and so if I take this data 1, I am printing the data 1. So when I print the data 1, I have 70, 75, 80, 85, 90, 95, 90, 75. So this is basically an array. This is an array, and let us see df, what the df is actually. So this is df. So these are the English marks here, 70, 75, 80, again in the last 75. So that is what is it has printed above in this. Okay. So this is what we have taken. So we have extracted one column, one attribute or column from this data frame, and I am assigning that it is basically, it is nothing but a Pandas series. So this is assigned to data 1. So let us try to find the data type of this array. So data 1 dot d types, it is attribute of this series. Now when I execute this, it is giving numpy nd array object has no attribute d types. Okay. So it is it won't support this series, the Pandas data series. It won't support any data types. Why it won't support? See, I will execute the next instruction, next command, and I will show you. So here when I ask you for the type of this data one is nothing but numpy ND array. So numpy ND array of 64-bit integers basically. So this is because this is an array, numpy array. It is a homogeneous array. All the elements. So where I have this, in this array, all the elements are of same type. That is 64-bit integers into 64. So then finding the data types. When I execute this one, what is happening? It is giving an error. So what is that error? This is what? Data 1 dot D type. So the different data types won't arise here. So that is the reason it is giving the because different elements in this array are not of different data types. So it is only single data type. That's why this data one won't support any data types, because there is only one data type, and that data type I can get by using the type instruction here. Okay, type command. Now, next what I am doing, I am extracting the attribute or column from the Pandas data frame by name, student name. The student name I am taking out, and its values I am trying to print directly. So let me print this. So this is what I am printing. So this is Deviation here. If you see here, Deviation. This is the array. Deviation, Johita, Deviation, Johita. Again, repetitions. Two names are repeating here. Sri Ram, Sujan, Krishna. Two times again it is repeating. The data type is object. Okay. So this we have already seen when we executed the command method df.info. So these are the values available. And what are the unique values among these? Here, when I say how many values are there, 8 values are there. But Divyanshu is repeating, Juhita is repeating, Krishna is repeating. Three names are repeating here. So let us find the unique values, different values. So the different values are Divyanshu, Johita, Sri Ram, Sujan, and Krishna. So repetitions are removed here. So these are the unique values. Now let us find the value counts. So these are the values here. These are the values. Now I am going to find the count of these values. Each value how many times is occurring. That is what this command gives. Okay. So here if you see Divyanshu twice, Juhita twice, Krishna twice, Sri Ram only one time, Srujan only once. Okay. So these are how many times it is occurring. That is what it is showing. So here, now take the another attribute, that is marks in English. Same thing. I am executing this here. I have printed the array here. Array is printed here. Then out of this, how many are repeating? 70. 70 is not repeating. 75 is repeating. Here 75 is there. 75 is there. Then 90 it is repeating. So let us find the unique values here. So if I find the unique values, they are 70, 75, because 75 only once it is printing, 90 also only once. Okay. So this is now the length has become only 6 out of 8. 2 are repeating. So the distinct values are now 6. And let us see the counts. It's just repetition of the above. Here 75 2 times it has occurred, 90 2 times, 70 and 70, 80, 85, 95 only once. Okay, this is again the count. Now let us do some arithmetic operations on this. And here I have taken the English marks in English column, and I am using the method. I am applying the method sum on this column, that is sum of values, sum of all values, that is total number of marks. So when I executed this instruction, I am getting 660. So summation of all these things. Here if you see summation of all these things, so see my cursor, I am selecting this one, summation of all these things. This is nothing but 660. Then another one, mean. Let us find the mean. So 660 divided by 8 is nothing but 82.5 mean value. Then standard deviation. I have the standard deviation here. The standard deviation is 80.86. So how I get the standard deviation? So mean and standard deviation, what kind of formula I used? So here, so I am just reminding you what is the standard deviation for the useful for the beginners. So here let us say I have X set of values, an array, and which has X1, X2, etc., etc., Xn. Okay. Xn are there. I think I can use this. So this is, I can say that X bar equal to summation of I equal to 1 to n, that is xi by n. So this is mean. Now what I am doing, I am subtracting this mean from every value, that is xi minus x bar. Then take the square. So this is xi minus x bar is called the spread. And I am taking, because this can be negative or positive, I am taking the square. Then I am summing this one. So when I am summing this one, again summing over I equal to 1 to n. Then I want to, this is sum of squares. Now mean square, I want to take mean means again n. So now what I have to take? I have to take the square root of this one. So this is nothing but your root mean square RMS value. So RMS value. So RMS value means root mean square. It is nothing but standard deviation. Okay. It is also called as standard deviation. So these are the calculations which are done in that instruction, whatever I have shown. So again, let us move to the programming window. So this is what is the standard deviation. If you subtract 82.5 mean from every value that is available in the column, then take the square, take the sum, then find the mean value of the sum, that is divided by n, divide by 8 here, then take the square root. So you will get, this is the 8.86 as the standard deviation or RMS value. This is also called as root mean square value. Now, so these are the sum, mean, standard deviation. Now, let us see some more description, statistical description of this data as the data frame totally. Let us see column wise. So I am executing this df.describe method. This describe method is used to provide summary of the statistics. Okay, it is basically this describe method provides the statistical summary of the data inside the data frame. Okay, so let me execute this. So this is what we have here. The roll number was an object and student name was also object. So we cannot find any mean value or statistical summations for the strings. So that is the reason they are eliminated. And the describe method will give the statistics only for the numerical attributes. So this is what we have. And in this one, first one we have the count 8, 8, 8. There are 3 columns: English marks, physics marks, and maths marks. Only 3 are there. The remaining 2 are objects. So you cannot find any statistical averages there. So what is the first one? Count 8, 8, 8. All are 8 values. And what is the other statistical average? Mean. Mean is nothing but 82.5 for English marks, 85.375 for physics marks, 88.125 for marks in mathematics. Okay. Then standard deviation. 8.86 for English, 8.17 for physics, 7.49 for mathematics marks. Then we have one more. This is the mean and standard deviation, these two. Then we have the rank statistics. What are the rank statistics? We don't calculate anything there. We just pick the value. We sort the values column wise. In that one, what is the minimum value? We will find. What is the maximum value? We will find. And what is the 25% quartile value? First quartile, second quartile, third quartile. So Q1, this is Q1 value, Q2 value, Q3 value. What it means? Minimum means that is the lowest one. No value is less than this. All values are more than this. Okay. Then 25% quartile means there are 25% of the values. For example, if I am showing here, okay, I will discuss this again. So 25% of the values of the given number of values fall below this value and 75% above this value. Then 50% value means 50% of the values lie below this value and 50% lies above this value. So what it means, it is nothing but median. So this is the 75%. That means after you sort all the values from minimum to maximum, then 75% of the values will fall below this, 25% of the values are above this one. And what about maximum? All values are below this, no value is above this. Okay, that is the maximum. So that's why minimum 25%, 55%, 75% and maximum values, they are called the rank statistics. Okay, these are statistical averages. These are rank statistics. Okay, you should be very careful about that one terminology. Then let us see the minimum value. Minimum value in English marks is 70. Minimum value is 75 in case of physics, 75 again in case of mathematics. So 25% quantile value is first quartile is 75 means. So that means what it means? There are 8 values. There are 2 values less than or equal to 75 because 70 and 75. Okay. Then in physics, the 25% quartile value is 80. That means 25% of the 2 values are below or equal to 80. All are above 80. The remaining 6 are above 80. Okay. Then 83.75. Same thing here also. Okay. Now let us see the 50% value. 50% value means average 82.5. Why you got 82.5? Real number why we got is, if I sort this one, if I take them, I have to take the middle value. Because I am sorting 8 values, they are even number. So middle means I will get the 2 values in the middle. 3 below the 2 values and 3 above the 2 values. So in the middle I have the 2 values. Then when I am finding the median value, I have to take the average of this value. That's why I got some fractional value here. Okay. Similarly, everywhere I am getting, because it is 8 values. What is that? 1, 2, 3, 4, 5. I am taking the 4th and 5th values. 4th and 5th values. 4th value plus 5th value divided by 2. So that is the reason I am always getting the decimal fraction here. Okay, decimal number here. So and 75% means 90. So there are 75% of the values are less than are equal to 90. So only 75% values means 6 out of 8. 6 out of values are below or equal to 90. Only 2 values are above this one. Okay. So that is what you have. And what is the maximum value? 95, 98 in physics, 96 in mathematics. So this is the summary of the statistical averages, 2 statistical averages and 5 rank statistics. Okay. And the first one is count. So total how many, the describe method will produce how many parameters here? Count 1, 2, 3, 3 plus 5. 8 parameters it will produce. So it is basically to know something. That means these are useful to explore the data. What kind of data? What is the mean value? What is the average value? Some kind of information we will get about the data in the data frame. Now, let us see here. Count equal to DF. Marks English I am taking. Value counts I am taking. And sorting the index. So what I am getting here? What is the index here? Sorting index means rows. So here I am finding the counts, value counts are given, but sorting. Because 76, 70, 75, 80, 85, I have sorted these marks. And then according to the sorted list, row sorting I have done. I mean, I should say row wise. So this is the sorting is done. And these values, now according to the sorted values, they are given. Okay. If I don't sort this, if I use only value counts, this is what I will get. Okay, counts, I am printing it count. So this is what you have. If you see here, the difference between, if I don't sort, 75 is coming first, then 90 and 70 again. After 90, 70 is coming. So it is sorting in the count. It is sorting this count. First 2's higher count to lower count, decreasing order. So 2 here, 2 here. Okay, when I sort, I am sorting the marks here. And then according to the sorted list, I am getting the count here. Okay, so that is the only difference. So this will be useful. This will be useful to find the maximum, mode value, something like that, which I will be discussing later. And here, let us take another one, that is student name values. I have executed this. What I am getting after execution, that means I am printing the values contained in the column, data frame column, title with the label student name. Okay, so student name here, space is there between student and name. It is a space part of the string. It is a part of the label. Okay, it is not that I have forgotten underscore here, as I told you in the previous lecture. So you can use the spaces also in the labels. Now, in this one, how many values are there? 8 values are there. So 8 values, Devianshu, Juhita, Devianshu again, Juhita, Sriram, Sujan, Krishna and Krishna. Okay. Now, what I am doing, I am declaring a list of names, that is Juhita here, not in this one. See in the editor, here names are there. Okay. So let me execute this directly. So I have here names, Juhita and Krishna is a list of 2 names I have taken. And what I am checking, I am taking the student name column attribute. Okay. And see the editor attribute and is in method I am using. That means these names, whatever I specified, are they available in this column? I am checking. I want to check whether these 2 names are in this column or not. Okay, that is the ultimate thing. So I have executed already names. I am executing now flags. Flags equal to what I have done here. So there are 8 student names are there. That is what I have. 8 students are there here. Same things here. And I have declared 2 names here. If these 2 names are contained in this, when there is a match, then I will get true, otherwise false. So first name is Deviation here. See my cursor here with blue color. I am highlighting this. So this name Deviation, it is a new name which is not there in this. That's why false. I got false here. Now second name is Juhita. Juhita is there in my given list. So it is true. That name is contained in this. So similarly, this is Juhita, I think. This is Juhita. This fourth one. Then GH, if you see, true is there. G is Krishna. H is Krishna. So this Krishna is also contained in this. I got the true. So these are the Boolean. So this is, if you see here, this is D type is Boolean. Okay. Because after you apply this, these flags, they are Boolean basically. Okay. Flag is nothing but Boolean. So now I am printing this Boolean. Same thing. Okay. I got this already. Then DF flags. So what I am doing, I am indexing the data frame with these Boolean variables. Okay. So whenever there is a true, those values only. Whenever there is a true in this Boolean expression, the values in the data frame are listed. Otherwise, they are not listed. So here, how many trues are there? B is true, D is true, G is true, H is true. So 4 trues are there. So corresponding to this, in this data frame, it prints only those 4 items. Means 4 rows here. Okay. So here it is, see here, B is true and B column is printed here. So D is there, then G is there, then H is there. These are the printed here. So basically, this is the Boolean type of indexing. Okay, earlier we have not discussed this. So that's why I am highlighting this one. So this is Boolean variables also can be used to index or to slice the data frame. Now similar one, let us consider this similar one. So what is this? I am declaring marks, a list of marks or array, you can say 95, 98, 2 values. So what I want to do now, these marks are there in marks underscore maths. So in the attribute of mathematics marks, 95 and 98 are available or not? That is my question. Okay. So that is what, again I am generating a flag here. Whenever this condition is satisfied, I will get a true, otherwise it is false. So let me execute this. So here when I see only one true is there, that is E. So I am extracting that indexed one. Okay. So this is what you have, E here only true. So here I have the only one Sri Ram is there where this is contained. Okay. So because one of these things, 95 or 98. Okay. 95 is contained here. And 95 is contained where? It is in the mathematics marks. Now let us see, same thing let us do for physics marks also. So when I see physics marks, where are the physics marks for me? So let me print these physics marks. Only physics marks I am printing now. So these are the physics marks here. In this one, I want to find whether 95 and 98 are there or not. So 95 is there here. 95 and 98 both are there. That means A row and H row. 2 rows are there. Okay. So that is the reason. So when I printed this, I am getting the result as these 2. So this is considering only the physics marks here. 95, 98. Okay. 95 and 98. Other things are not considered. So this is the basic thing used for extracting the information. Okay. So this is what you have. Now let us discuss or demonstrate another method called filter. So this is another method called filter. In this method, I am going to filter the items, whatever is needed. Okay, whatever. Here, what I am doing, the filter takes items. That means a list. Items is nothing but a list. List of what? List of column labels. It takes, then in this case, it is roll number and marks in English. I am giving this as items and I am trying to filter the data frame. So what is happening here? So it is basically extracting. It is nothing but extracting the columns in this case. Okay. Now similarly extract the student name and marks in mathematics. Okay. So initially roll numbers and marks in English we have extracted using the filter. Now student name and marks in mathematics we have extracted like this. Okay. So this is the student name first column. Second column is marks in mathematics. Now let us do some more experiments. Student name and marks mathematics, again I am executing this one. It is already executed, but still to be on safe side I will execute this one. So I have this filtered output. It contains only two columns. One is object, student name object, and other one is marks in mathematics array. Okay. Now let us do some kind of filtering. Here what I am doing, df dot filter like equal to stu. So the like is students, stu along axis 1. Okay. So let us, after execution of that one, let us see the result. So what is the result we got here? Like stu. Axis is 1. Okay. Now what it means is, it is in this label student name only I have the stu. In other labels, in other column labels, there is no stu string. There is no this string. Okay. So that is the reason it is printing only the column which contains the stu string. Now let us give another string phy, capital P H Y. So here it is only physics. In the physics it contains, so it is giving this only one column. The other one is basically index A B C D E H is nothing but row index. Okay, we have to consider only this basically. Okay, only the marks in physics. So that is what is along x-axis. Now let us filter along axis 0. So filtering is done in row, using row labels basically. Now you are searching for a letter A along axis 0. So let us execute this and justify the result. So here A is there. This is the label, correct? Row label is A. So this is what you have. So df, I will print df again. So this is what you have. This is what is you have A. In the row labels, only A is contained in the first row. In other rows, they are B, C, D, E. There is no repetition of A. There is no A is not contained in this. So what it is doing? It is printing only the first row. Then what about the other one? df dot filter like equal to f string along axis equal to 0. Again same thing along the row. Row wise, and row labels when I check at only one row, that is f row, that is nothing but 6th row only you have this f is occurring in the row labels. So that row label, the row with that label f is printed here. Now let us do another filter operation, and here we use the regular expressions. It is called a regular expression. So in this case you have to here this regular expression equal to this string. So that means it must contain capital P. So this is along by default. X is equal to, I should say 1. X is equal to 1 by default. If you don't specify the axis, I am just keeping it here. So for your reference, so default is X is equal to 0. So in that case, what is happening? I am again executing this. So here this is marks and underscore P, capital P, which is case sensitive. You should consider that also. And capital P only it has printed. And marks in physics, marks underscore physics contains this character P. So only that column is printed. Now let us take df dot filter regular expression equal to underscore P. So what is the string to inquiring? You are inquiring underscore P. That means 2 characters are there here. Either underscore or P. Any of these characters. So here let us execute this one. When I execute this one, this is what we have. So what it means? Because the default along axis 1, that is we are searching within the column labels here. In this one underscore P, underscore P, underscore is there at 3 places, 3 columns in 3 labels. Okay. So that's why all 3 are there. And P is anyway contained in this one. So all 3 columns are printed here. Okay. So this is, one is using like argument, giving the like argument here and giving the regular expression here. There are 2 ways. And you can do the search process along x-axis. Along x-axis means 0th axis. That is along columns or axis 1 along the rows. Okay. That is what you have. Now, let us do some more search on this. Here, we are using string dot contains. This is the string dot contains. Whether this series, this is the one column, student name column, available in the Pandas data frame. Only single column I am taking. In that one, string dot contains. In this string, HNA, the 3 letters are contained or not. That is what I am going to check. So here, let me print the condition here. I am printing the condition. It is a boolean variable like flags earlier. I am just printing it here for your reference, for your later reference. And this is the, except for G and H. At other places, HNA is not there. So in the, what is the difference between this one? Difference between this, for example, DF filter this, and these are almost similar. String contains. Here, each character separately is searched. Each character, one of the characters. If I give 2 characters, either of these characters must be there. But in this case, all together as it is. The string, it is not the letter character. It is the string HNA of 3 characters. It is searched like that. Okay. So there is almost similar, but this is for to search strings here. Of multiple characters. Here, character by character, if I want to search, you have to use this. That is the difference between the str dot contains and filter one. Okay. So that is what you have. Let us print this condition I have printed. So when I print this, I have G and H is true. So only these 2 it has printed, because in the values I have the Krishna and Krishna HNA is available only for G and H rows. Now let us see this. Let me print this condition here also, so that we can see the Boolean expressions also. So here, what is that I am doing here? The condition is marks in mathematics should be greater than or equal to 95. Okay, let me execute this first. Then I will explain in the console together. Okay. So here, this is the code I have executed. This is the instruction. In this one, I am verifying the mathematics marks in mathematics. I am checking whether these marks are greater than or equal to 95, or this is the or condition, or marks in English are greater than 80. Okay, you should be careful. It is only greater than 80. Equal to 80 is not considered. Here greater than or equal to 95. Both 95 and above 95 is considered. Here more than 80. Not equal to 80. Okay, so that is the condition. And when I see the condition here, it is a Boolean. It is Boolean array actually, because all are Booleans only. Then in this one, the first three are false. D, E, F, G, H. Last 5 rows, they are true. How they are true? Let us print this and check up here. DF. And DEF, last DF, last 5. Okay. So let us execute this probably once again, or print the condition. Okay. So here D, if I take D here, this is what we have. And true. What is the condition for us? See here. Condition is, this is the condition. Marks in mathematics must be greater than or equal to 95. Marks in English must be greater than 80. Okay. Let us come back to this. And in this one, if I take, what are the marks in English? 85. And what about marks in mathematics? English 85, mathematics 75. Okay. So this is what you have, and it is showing true. So again, I just want to see this greater than mathematics marks and English marks greater than 80. Greater than 80. Here, R condition is there. Okay, one of these things. So one of these things, okay, let me print this and again, because I'm moving forward and backward to avoid that one, we can have this. Okay, so this is what is the Boolean condition. This is the Boolean type indexing. I extracted the rows from DF which are satisfying this condition. What is that condition? Mathematics marks must be greater than or equal to 95. So here, greater than or equal to 95 means it is satisfied in case of E and in case of H. E and H. In case of E and H, this condition is satisfied. Or, what is the other condition? See here, other condition is marks in English is greater than 80. That is the other condition. So when I take English, so here in the case of D, 85 marks, then E is already satisfied in that one. Okay, whether it is satisfied here or not doesn't matter. Now take F, it is above 95, and G 90, and H, this is because of this 96. Okay, not because of this, because this is less than, English marks are less than 80, but still it is showing because of this 96. Okay, so it is basically the R operation, two conditions, union of two sets basically. Then let us see the other one, that is DF marks mathematics greater than or equal to 95. First condition is same. Yeah, second condition is also same. I think it is just repetition. So let me go to the next one. So probably yeah. So I think I need now. I don't need this. It is repetition. So let us come to the last condition here. That is, I will execute this first and I will explain. Then come to this. This is the condition. What is this condition? Mathematics marks should be equal to exactly 90. Not less than 90. Not greater than 90. Exactly equal to 90. Then marks in English must be greater than 80. It is already previous condition only. Again, I am using the R operation. Okay. So this is what you have. This is what you have. The output, it is here mathematics marks equal to 90. Mathematics marks 90. So here 90. Only in this condition it is satisfied. All other conditions greater than 80 of English. So this is these things because of this. 85, 90, 95, 90. So because of this, it is R. Okay. I think I did a mistake. I think let me undo this one. Let me check this one. Just I could remember now. So here the difference is AND. Here there is OR operation, union operation. This is intersection. So this is what I am executing. This is also useful. So let me execute this one. So here, when I executed the OR, this is what I have. When I executed this is OR, what originally I have shown here. Okay. Again, I will execute this AND operation. So AND operation is only one. That means what is this condition here? Because OR operation has more options, more hits there. Then here, greater than or equal to 95 and 80. So both conditions should be satisfied at a time. So maths, what are the maths here? Maths marks are here. Greater than 95 means 1, 95 and 96. These two. In these two, what about the English marks here? Greater than 80. So 96, 95. So second row I have to compare. English satisfied. 90 satisfied. Then what about this one? This is 75. So it is not satisfied. So out of E and H, it has selected, the condition is satisfied, AND operation is satisfied only for E. So that is the reason for this condition we are getting the result of only single row. That is, so I think I have done sufficient exercises on testing this. What are the things, to summarize, what are the things we have done here? Some statistical means, unique values, value counts we have done, and initially we have did the size analysis, what kind of size, dimensions, etc. and statistical summary by using the dictionary. Then we have extracted the values and we checked whether these given list values are available in this. Similarly, marks are available in this. So it is basically you are trying to retrieve the total columns which satisfy the particular condition. Then I used the filters. So this filter method I use, and this is also the same thing. And you are extracting, and you are searching for the strings. You are searching for the characters afterward. Again, you use like here, and use like here, and so it is a characters. Row indices and vertical row indices and column indices, row labels, column labels, and using the like filter, like argument, and regular expression also I used here. Then after that, I use the these are relational operations, and we are comparing here relational operators, and these are the logical operations, or AND. Okay, these are logical operators. Don't confuse this with the bitwise operations. Okay, bit or ORing and bit ending, they are different. So here we are talking about only logical OR and logical ending. Okay, so this is what we have for today. Thank you so much for your attention. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.